but let's look at it. So it says how many cards are there in a standard deck of playing cards? So I had categorical data for 2 of us. The rest of us were thinking numerical. Would someone who claimed numerical care to explain why?
Because it's how many cards.
It's how many.
It's how many.
Ask for a number.
It's asking for a number, right? If someone asks you how many cards are in a deck of playing cards, you better give them a number response.
Your answer is a number.
Your answer is a number. Okay? But we're a little split on statistical versus non-statistical. Now, really quickly, when I say a standard deck of playing cards, you need to be aware that this only means one thing. What is a standard deck of playing cards? No one knows?
Regular playing cards.
Regular playing cards? What do regular playing cards look like?
They got numbers on them.
They got numbers on them, 2 through
10.
2 through 10, and then Jack, Queen, King,
Joker,
Ace. Standard deck, we don't include the jokers, but we have diamonds, we got spades, clubs. What am I missing? Hearts, thank you. Right, so that's our standard deck of playing cards. Now from there, Bree, what is the difference between a statistical question and a non-statistical question?
Non-statistical is like, don't call me out like that. I gotta think about my course next first.
Whoa, guys, how long have we been talking about statistical versus non-statistical questions?
But long,
For way too long for us to not know that answer. Way too long.
all the time.
Brayden, what do we mean by a non-statistical question or by a statistical question?
In a non-statistical question, there's no variability.
Okay, no variability. There's a little bit more that we want to add to that. Does anyone know what there should be no variability in? The response, right? So there should, if it's a non-statistical question, there's no variability in the response. It's an answer that we should know. Okay? Whereas a statistical question would be what, Devin? Variability in what? In the what? In the just response. Remember, if it's numerical, the response will be a number, right? If we talk about my weight versus, I would assume anybody's weight here, we would have different responses for what our weight is, right?
I'm not
So
so
the-
260.
Okay, so there will be variability in that numerical data, but you can also have variability in categorical data. Remember how we talked about what is your favorite sport, right? There could be variability in that as well. So, but it's the variability in the responses. Does anyone know how many cards are in a standard deck of playing cards?
64.
Not 32, not 64.
53. 29.
Oh my gosh.
30. 78.
We're all over the place.
27.
First off, how many suits are there?
I don't know. There's how many?
Suits. There's 4, right? There are spades, there's hearts, there's diamonds, and clubs. Thank you. There are 4 suits. Every suit has the numbers 2 through 10. How many numbers is that?
8, 10, 9. I don't know.
How many numbers are there from 1 to 10? 10.
No, it's not. Well, you gotta count
From 1
to 10.
through 10,
Oh,
there are
10.
10 numbers. So if we're missing the 1, there's going to be 9. Okay? You were guessing, right?
Nine.
So there's 9 for the numbers, and then there's the Jack, Queen, King, Ace.
And let's be
So plus 4 means that we have 13, 13, 13, and 13 for a total of
36.
52.
I said.
honest.
I said 53.
Yeah, 53 is
I
not
was
52.
hard out.
Okay, more importantly, if I ask someone and if they know the answer, is there ever going to be variability in the response?
No.
No. A
Unless-
standard deck of playing cards has 52 cards.
Unless they add extra card on that. I don't even remember.
But even if they do that, are they correct? Now, if I were to ask you, how many cards do you think are in a standard deck of playing cards? Could I get a variability in that response? Heck yeah. But just how many cards are in that standard deck, there's no variability. So which answer should we go with?
Non-statistical.
Non-statistical.
Can you see what answer I clicked?
You're not in that group.
Oh, never mind.
Kyron, you were in the statistical with numerical data.
I remember I clicked one that I was able to change.
Alright, so here's the next question. Identify the type, or what is the favorite subject of students at Hillcrest High School? The most common response was definitely categorical data. Anybody care to share why they were thinking numerical? Because I have a pretty good inkling. It was something we talked about last week, but I'm willing to bet this is what we're thinking.
Show the names.
Huh?
Show the names.
You want me to call them out like that?
You called us out last time, because I had.
Here's the thing. I'm going to call people out by showing the names if one person does not volunteer to say why they're thinking numerical. Just one person has to step up and be like, alright, Mr. Kenny, I was one of them.
Show the names.
I guess.
No,
You thought numerical? What were you? Wait, just tell me why you were thinking numerical.
I didn't think about like this.
Okay.
You just saved my life.
But now you already told us, Bree. You could have just said something, right? Let me ask you this, and this is what you need to think of. So that's the overall question, right? That's the question that's trying to be answered. The survey question, remember though, is the question you might ask someone. Brianna, what is your favorite subject in school? Science? Okay. Is that a numerical value or is that a category?
Category.
That's a category, right? So think about the survey question. What would you ask somebody? You're going to get categorical data there. And then we have statistical question, right? Versus non-statistical. Mia, what is your favorite subject in school? That is not a subject you study. That may be your favorite class. That is not a subject you study.
I don't have one.
You don't have any single favorite.
Math.
Math.
No, you lie.
I appreciate the
Math
suck
is
up.
my favorite
All right,
subject.
regardless though, did Brianna and Mia give the same response?
Yep.
Nope. So what kind of question is it? It is categorical. They gave me categories, but was it statistical or non-statistical?
Statistical.
Statistical.
Alright, now show the names.
I'm not showing names this time.
Caroline.
Alright, so the equations, 5x minus 3 equals 2x plus 2 times x plus 1, and 5x equals 2x plus 5 are equivalent. I got some trues and I got some falses. Pretty split on that one, yeah?
Yeah.
How are we supposed to figure this out?
So,
Solve it? What do you mean by solve it?
like, do some math up in there.
Do some math up in there, but what do you, so if we were to say solve, what do you really mean by solve?
Or.
Find the solution, so to find the value that what? That makes that statement, in this case an equation, true, right? If you're going to solve, then you need to find the value that makes that equation true. However, do you actually need to solve to figure out if these are equivalent?
No.
No. What can we use instead?
Maybe a pipe.
Say it one more time.
Maybe a pipe.
We can use the distributive property. That's a great place to start, right? The distributive property. Alright, so 5x minus 3 is equal to 2x plus 2. Do these look exactly the same?
Yep.
Do they?
No.
No.
They look close, but are they exactly the same?
No.
No. Are they still equivalent? Yes, because I use that distributive property, right? So distributive property helps me create equivalent equations. Does anyone see another move that I could use to
Subtract 2x from.
Add the 3.
So hold on one second, because I know where you're going. I know where you're going. Bree, are you trying to solve this equation?
No. Just
Are you
trying to
sure?
make it equivalent to.
You're trying to make it equivalent to this.
Yeah.
Do we need to subtract 2x though to make them equivalent?
Oh no, add that 3.
Which was what Kyron was saying, right?
Yeah.
Notice the 2x is in both of these.
That's big as 5.
So why is Kyron saying add 3?
So it can equal to 5 over there.
1, if I add 3 to 2, that gives me a 5, doesn't it?
Yup.
Also, if I look at the left-hand side, what is this missing?
The 5 is by.
And-
Look at
three.
The 5
It's
is
missing
by
that 3,
itself.
right? That's all I'm saying, right? The 5x here is by itself.
Oh, yeah.
So if I add 3, hey, what's negative 3 plus 3?
0.
0. Notice, I don't just say it cancels, I say it is a 0. Okay? But notice 5x minus 0 is 5x.
It's 2x plus 5.
It equals 2x plus 5. Notice if I don't do anything to the right hand side, will it be equivalent?
No.
Nope. What am I using when I add 3 to both
Property
hand
of
sides?
equality.
Which one?
Addition.
Notice how I added, so it's addition. I maintained equivalency, so it is a property of
Equality.
equality. It's addition, property of equality. Hey, are those the same equations?
Yep.
Yo.
Did I have to go through all the work of solving for x?
No.
Nope. You can, but it's more difficult, right? We actually want to understand equivalency first. Okay, by the way, does everyone see who said false, why this is actually a true statement? If we'd all gotten it right, I would have just skipped over it, but we need to address that. So if they're equivalent, we can use those properties of equality to show that they're exactly the same. Now, this next question, this is important. This is a slightly different question. It says the equations, by the way, y'all don't have this written down, so it's okay.
I don't even know which one I picked.
Okay.
I think I should.
Alright. The equations 3 times x minus 2 plus 1 is equal to 2x plus 4. And 3x minus 5 equals 5x plus 4 minus 3x. And the question is, or the equations have the same solution. Okay, true, that solution is 22. B says true, the equations are not equivalent. C says true, the equations are equivalent. And D, false, the equations are not equivalent. If equations are not equivalent, do they have the same solution?
No.
No. Remember, only if they're equivalent do they have the same solution. So, for those of us who picked B, was it just we didn't read it closely?
I read it wrong.
Say again?
I read it wrong.
You read it wrong? Okay. So be careful with the reading, because that's an important detail here. True, the equations are not equivalent. Alright, that is just a contradictory piece of information. It would either have to be C or D in that case. A, true, that solution is 22. Anybody willing to say, hey, that was me?
Call him out. I did, so I can't tell you who I did.
I
Y'all.
don't remember. I think I
Mr.
did
Kenny,
something.
my brain hurting, I'm tired.
Can you click on this?
It's the first 5 minutes.
I think I got
No,
a deal.
but still.
Somebody looks suspicious.
I work every day, so I'm just saying.
Maybe you're right over there?
Click D first.
I know what she's
So
doing.
we're there. No, I ain't see. Wait, go back. Oh, it's all good. Hey, man. Hey, whoa. Do we make mistakes?
Yep.
Are you good enough to make fun of someone else for making a mistake?
No.
No.
We're
You
all
a whole
human.
lie. All right. Maven, why were you thinking, Jose? You just put us on the stop doing that. We gotta think through this stuff.
Can you see which one I picked and I tell you why I picked it?
It's fine now.
Oh, that boy stepping out his shell today.
Right.
Good evening, everyone.
I did.
I knew it was D.
Yeah, you said D. False. The equations are not equivalent.
I ain't picked up that.
So, I mean, these are pretty complicated equations. So I will point out the solution is not 22. If you substitute 22 into these equations, it does not make the equation true. I'll show you where I got 22 from in a minute. Okay, what can I do to figure out if they have the same solution? We already said it. The equations need to be what? Equivalent, right? So what can I do to figure out if they're equivalent? Nothing? Nobody? We didn't just do a problem just like this?
No.
What's a property I can use to start?
A to property.
Can I use distributive?
Yo.
Yeah. Alright, so 3x minus 6
So 1.
plus 1 is equal to 2x plus 4.
Yo.
Anything else that I can do?
You can add that 1 and that's it. Yo.
And then the 6 plus 1.
Notice, what am I doing when I take that negative 6 and I add the 1 to it? Is
Combine
that
like terms.
combining like terms? There's an S word that we can use there as well.
Simplify.
Simplifying, right? Taking a more complicated expression and making it simpler, right? We simplify the negative 6 plus 1. So 3x minus 5 is equal to 2x plus 4. Huh. I mean, the left-hand side's already the same. What do I need to do?
Subtract.
Subtract what?
So solving for x and
No.
Add.
You can. No. You can flip it.
You can either add 5 to the other side, or you
Uh-huh.
can subtract 2 from that other side.
Yeah.
I don't know my left, my right.
But remember, I'm trying to show that this is equivalent to
It's
this.
already the same, you just gotta flip
Oh, all you
it.
gotta do is just go to that side and subtract 3 from 5x.
So what's the word that we would use there?
Simplify.
Simplify, right? Could I take 5x and subtract that 3x?
Yo. I don't know.
See, I ain't do all that, I just guessed.
Exactly.
Yeah, quit guessing.
Let's see.
Hey, are those equivalent?
Yep.
Yup.
Yup.
Here's the thing though, guessing is not gonna help you prepare for understanding checks and quizzes and things like that.
That was too long to write down, then by the time I get ready to
Like,
work out.
educated can't see
I
how
was
to do
I
it.
gave up.
You could have done it in
I
the
learned
time I
that
gave.
science.
Oh, I kinda.
Alright, one thing I will point out is you could also just say, hey, that 2x is the same as 5x minus 3x, and just rewrite that 2x as 5x minus 3x. You could have done it that way as well. Anyways, let's get going with the day. So, let's go to the agenda.
Bro, what, man? Hey, look at hell.
By the way, did y'all notice how this is a little bit bigger? Definitely is. I figured out how to make the picture bigger, which was exciting because this morning it was tiny. They could not read it, and I felt terrible. That's right. I played around with things on the computer.
Yes, sir. Yes, sir. You guys-
Actually, I Googled things. Google, my best friend, when I
Yeah,
can't figure
you
crap
cheat.
out.
Cheat.
No, I'm not
Yeah, you
cheating.
cheated.
No, it's not.
Uh-huh.
That's not a quiz
You
or a
got to
test.
Google my answers on my test. You can't do it on your.
It's not a test.
Doesn't matter.
Well, you keep
So use
thinking
your
that.
brain,
I
not Google.
I did use my brain with Google.
Okay, so I can use my brain with photo now.
No, good try.
Yay.
Alright, so remember what we're doing is within this review about equations and equalities, we were practicing that classroom culture. Remember all those norms, the expectations that we agreed upon for each other of working within our group actively the whole time, staying awake, and things like that is important for learning. So we're going to work on lessons 8 and 9. Hopefully we'll get through those somewhat quickly. We'll have a break to ask some homework questions. And then the quiz that I told y'all about on Friday, that may slightly change. I'll explain more about that later.
Wait, what?
The quiz I told y'all about on Friday.
I was asleep.
I was out of there.
Alright, so that may change to first thing tomorrow. We'll figure
I
that
hope.
out. It's
I'm
not just a
praying.
yes, Mr. Kinney, because I didn't study, even though you told me to, Mr. Kinney.
I wasn't
It
here.
de- Oh yeah, you're right.
I wasn't here.
We're not here. Oh, that is one thing I want to quickly address, right? There are still things that you can definitely do on the quiz. Also, my quiz policy is very different than some people's. What matters to me is not when you learn it, but that you learn it. Remember how I gave you feedback on your pre-assessment and I showed y'all feedback that I give in previous students?
Yo.
So I use that rubric to help me figure out how well you understand it, but also to give you feedback to help you develop your understanding better. If you learn from your mistakes on the quiz and you do better on the test for those same exact ideas, I'll honor that. Let's say you make a 65 on the quiz, but you make a 90 on the test on that portion, I'll replace your quiz grade with a 90 because you learned it to that level. It's not about when you learn it, it's that you learn it. Okay?
Well, I'm gonna learn.
What?
I'm gonna
I ain't gonna learn everything to the end of the school year.
That's it. No. It's by the test. Yeah. What were you gonna say there, Kyron?
I'm tired.
Okay.
I don't know.
And the whole point is that you still put in your best effort because if you don't know anything at all, I can't give you feedback.
I know.
You know a little bit? Okay. So, hopefully we'll get to lesson
Hey,
20.
bro. Wake up.
She's out cold. Alright. Someone I haven't called on recently to read
Kiara.
objectives.
Because I want to show y'all not.
With what glasses do I
You
have?
want to show me that you know how to read?
Yeah.
Alright, so
Tamia?
Key will get the second objective. Jaden starts off with the first objective.
Mr. Kenny, I
Hey,
can't see.
hey,
Did you say?
hey.
Shut up.
You
I'm trying
can't
to
see
read.
from there?
No.
Why
Lights
calling
off.
Key out like that?
I thought she could see. I thought you
Hey.
had contacts in. I was
Can
like,
I read?
No, I didn't
Excuse
lay
me.
down the drain.
Alright, Jaden, go for it.
Thanks.
Shut
Rude.
up.
I know, right though?
Give
You
me
know
the-
what?
I'm finna call
Go
this.
for it. Go for it.
Given an equation, I can solve for a particular variable like height, time, or length, when the equation would be more useful in that form.
Okay? And so we'll recap what that kind of looks like with the beginning of lesson 8 that we talked about on Friday. Caleb, can you read our second objective for us?
Know the meaning of the phrase to solve for a variable.
Alright, these are the two objectives that we need to be focused on for lessons 8 and 9, right? Given an equation, we need to be able to solve for a particular variable, which means how many variables are you probably looking at in each equation? 2 or more, right? Because you can solve for a particular variable to make your life easier, and that's kind of the point of solving for a variable, and we'll explore that more moving forward. And so one of the places we wrapped up, or one of the main ideas we wrapped up with, I believe, was here on number 2, deciding whether each equation could represent the relationship between B and A. And I think that's where we ended the day. Does that sound right? And I had y'all do a quick poll question. Does anyone remember which answer choices could show the relationship between the base and the area? C, D, B. Which one is it? Let's look at B.
It was
If I want the base, can I take the area and divide by 3? So did I take the area and divide by 3 to get that base of 12, right? 46.5 divided by 3, I think, was 15.5.
Yeah.
And that's what we had, right? And then, does anyone remember the other equation? D, as in dog, right? So if I want the area, I can take 3 and multiply it by the base. So 4.5 times 3, 13.5. 11 and halves times, not 2, 3 is 33 halves. And we saw that relationship with the 1 to 3, the 2 to the 6, right? And drop that. So does anyone remember why we might want these two different equations? Because this is an important reason for why we're even doing this lesson in the first place. Well, let me ask you this. If I have the base and I want the area, which equation am I probably going to use? If I have the base,
The second one.
so if I have the base and I want the area, I'm going to use this equation?
Wait, what you guys?
I said if I have the base and I want the area, which equation am I going to use? D as in A equals 3B? The second one here? So let's say my base is 5 and I want the area versus this one. Which one would be easier to work with?
No, second.
That's easier than this one?
I mean,
Yo, what's 3 times 5? 15. Do I need to even do anything else? No. Remember, I have the base and I want the area. That one's easier to work with because all I have to do is substitute and simplify. I don't even have to use inverses or properties of equality or anything. Okay? But if I have the area and I know the area is 21 inches squared, right? That's my area. Which equation would I want to use?
three.
This one, so right? Now, can I use either one? Yes. Now, so please hear me clearly. You can use either equation, but the point of this is, if I want the area, that equation is easier to use. If I want the length of the base, that equation is easier to use. So we want to highlight the variable of interest. I want the base, so the base equals. I want the area, so the area equals. Okay? That's the point of all this. And so we did not start on, I think this is 8.2 maybe? It would be on the back side. Yeah. We did not start on 8.2 by the end of class? No? Okay. So I need everyone's heads up so that I can establish a couple things because there was some confusion on this problem in first block. After a parade, a group of volunteers is helping to pick up the trash along a 2-mile stretch of road. The group wants to divide the lengths of the road so that each volunteer is responsible for cleaning up equal length sections. Number 1, find the length of a road section for each volunteer if there are the following number of volunteers. No matter how many volunteers there are, how much total road are we cleaning up? And the problem?
2 miles.
2 miles, right? It's not more complicated than that. Notice how the question is asking us to find the length of a road section for each volunteer. Now, the reason why I'm pointing that out is because you should be thinking about units in this case. Do not just do 2 times 8 or 2 divided by 8 or 8 divided by 2. That's not going to give you much information. At the end of this, because it's a length of road section for each volunteer, or a length of road section per volunteer, what should my units look like? Per, what should we think about if we see that per volunteer? What operation? Whenever we see per, it's either going to be multiplication or division. What do you think in this case, Maven? Did you say addition? No? It's okay. Listen, y'all. If you hear per, like miles per hour, we need to recognize that that is division. Okay? So, length of road section per volunteer. What would go in the numerator and what would go in the denominator? Would the miles go, or would the length of road section go in the numerator, or would it go in the denominator? So we think length of road section here, which means what will go in the numerator? How many volunteers, right? Pay attention to that if you think that that is correct. It is totally okay for you to explore other ways as well. Just remember, what we want is a length of road per volunteer, right? So this is a hypothesis, this is a guess, this is a prediction. Test it out. See if you need to play around with what goes in the numerator and what goes in the denominator to make sure that we get length of road per volunteer. Not telling you which one, I just want you to explore for a little bit, just like we did with math 1 to 100. You explore a little bit, I'll come by and ask questions within your group, push on your understanding, and then we'll have a whole class discussion afterwards. We clear on directions?
Wait.
Can I get a new partner?
No. You got good partners.
Get up.
Let's get to work. Kai, come on. Heads up. Key, head up.
Need to work.
Key. There's no way you fell asleep that quick.
Oh God, I do.